Welcome to the video. This video is about what is local minimum and local maximum value of a function. More specifically, following questions will be cleared. What is local minimum value of a function? What is local maximum value of a function? And how is local minimum and local maximum values different from absolute minimum and absolute maximum values of a function? So let's begin. So the first question, what is local minimum value of a function? So it is the value of a function lower than any other value nearby in some open interval. Or a more mathematical definition can be that it is the value of a function at a point k in some open interval such that f of k is less than or equal to f of x. So if this condition is satisfied, f of k is then the local minimum value of the function. Now coming to the definition of local maximum value. Local maximum value of the function is the value of a function greater than any other value nearby in some open interval. Similarly, a mathematical definition can be that it is the value of a function at a point k in some open interval such that f of k is greater than or equal to f of x. If this condition is satisfied, f of k is then the local maximum value of the function. Absolute maximum. It is the value of a function that is the maximum in its entire domain. While absolute minimum is the value of a function that is the lowest in its entire domain. Let me graphically show each of these terminologies and how one is different from the other. Consider an arbitrary function f of x and its graph below. Its domain is from a to d, whereas delta is a positive number greater than 0. Here a, b, c and d are the critical points. That is, at these locations, derivative of function either does not exist or is 0. Critical points are important because these are the location at which local minimum, local maximum, absolute minimum and absolute maximum values occur. Therefore, in the present example, we will look for values at these locations by applying different conditions. Consider an interval about critical point A. The interval is from A to A plus delta. So it is a small interval including critical point A. Similarly, consider an interval about critical point B. The interval is from B minus delta to b plus delta. Here the interval is an open interval, but it can also be taken as a closed interval. So it does not matter whether you take it as a closed interval or an open interval. So it is the second interval including critical point B. Similarly, consider an interval about critical point C. The interval is from C minus delta to C plus delta. So it is the third interval including critical point C. Consider another interval about critical point D. The interval is from d minus delta to d. So it is the fourth interval including critical point d. Let's analyze interval 1, that is from a to a plus delta. At this interval, if you look at the graph, at a the value of function is the lowest, which is f of a. That is, f of a is less than f of x in this interval. So by definition it is a local minimum point, and f of a is the local minimum value. Similarly, analyzing interval 2, that is from b minus delta to b plus delta. In this interval at b, the value of function is the maximum, which is f of b. That is, f of b is greater than f of x in this interval, so by definition it is a local maximum point. Similarly, for interval 3, that is from c minus delta to c plus delta. At c, the value of function is the lowest in the interval. That is, f of c is less than f of x in this interval. So by definition it is a local minimum point, and f of c is the local minimum value. For interval 4, that is from d minus delta to d, at d the value of function is the maximum. That is, f of d is greater than f of x in this whole interval. So by definition it is a local maximum point, and f of d is the local maximum value. So that's how you identify local minimum and local maximum value of function from the graph. Now absolute maximum, which is the greatest value of the function in the entire domain. Here the domain is from a to d, and by looking at the graph, absolute maximum occurs at d, and its value is f of d. Because f of d is the maximum value of the function in the entire domain, therefore it is absolute maximum value. Similarly, absolute minimum is the lowest value in the entire domain, which in this case occurs at a, and its value is f of a. So at point a, both local minimum and absolute minimum occurs. And at point d, both local maximum and absolute maximum occurs. So the bottom line is, every absolute maximum is also local maximum, but not every local maximum is absolute maximum, which is clear from the graph. Because at D, the absolute maximum is also local maximum, but at B, the local maximum is not absolute maximum because we have only one absolute maximum, and that is at D. Same is true for local minimum and absolute minimum values. That is, every absolute minimum is also local minimum, but every local minimum is not an absolute minimum. That is, at A we have the absolute minimum, which is also local minimum, but at C we have the local minimum, but it is not absolute minimum because absolute minimum occurs at A and its value is f of A. There can be only one absolute minimum and one absolute maximum, but there can be multiple local minimum and local maximum values. What if we change the domain of the function from A to D interval to -infinity to infinity? In this case, the critical points are B and C only. Previously, A and D were also critical points because derivative was undefined there, as they were the endpoints of the interval. As the derivative did not exist at A and D, therefore they were the critical points and was analyzed for local and absolute minimum and maximum values. But if the domain becomes from -infinity to infinity, the endpoints occur at infinity, and therefore the only critical points we are left with are B and C. Only these points will be analyzed for absolute and local minimum and maximum values. So at B, local maximum value occurs, and at C, local minimum value of the function occurs, while the absolute maximum value occurs at infinity because this graph is increasing to the right. Similarly, absolute minimum value occurs at -infinity because the graph decreases to the left. So in this case, we have local maximum value at B and local minimum values at C, but no absolute maximum and absolute minimum value occurs because the function is increasing to the right and decreasing to the left. So that's how local and absolute minimum and maximum values can be identified from the graph, and how local and absolute minimum and maximum values are different from each other. So thank you guys for watching this video, and if the video helped you, give it a thumbs up, comments on it, and subscribe for more.